Here we're given y as a function of x, y equals 3x squared minus x. We're interested at the x value 1 and a little bit more. Delta x equals 0.1. That will be the difference between our first x value 1 and our last x value, which will be the original 1 plus delta x. Then we're asked to find part A, delta y, that's a change in the y values, and part B, the differential dy, and then we'll take a look at how close they actually are to one another. So we're going to, for part A, where we're looking for delta x, we'll have to consider this picture. We're going to do a graph. Here's the y-axis, the x-axis, and it's the function y equals 3x squared minus x. Now let's look at x equals 1 and then add delta x to that to get the next x value, 1.1. The y value, the y partner to x equals 1 is f of 1. Evaluate the function 3x squared minus x at 1, you get 2. That's the y partner to x equals 1. The y partner to x equals 1.1 is derived the same way. Plug 1.1 into the function y equals 3x squared minus x and you get 2.53. That's the second y value. So you see we have this graph, and the distance between the x coordinates for these 2 points is called delta x. It is 1.1 minus 1. Well, it's given as 0.1. And then delta y is what we're looking for here. And you can see it already just by looking at the graph. Delta y is the y partner for the last x partner, which is 1.1, minus the y partner for the first x partner, which is 1. So it's f of 1.1 minus f of 1. That's 2.53 minus 2. So delta y is equal to 0.53. You could calculate that just by looking at the graph. That's part A. Let's do part B. The differential is defined to be f prime of x dx. So we use f of x equals 3x squared minus x, take the derivative, get 6x minus 1 times dx. Now, we know that delta x is very small. It's actually 0.1 in this problem. It's always going to be very small. So in calculating the approximation of dy, it's fair for us to use this assumption that dx is about the same as delta x. So instead of worrying about what dx is in this equation, we're going to let x equal 1 and dx be approximately delta x. So plug x equals 1 in there, and that simplifies to 5. And now let delta x be 0.1 and multiply 5 times 0.1. And we get delta dy, the differential, is equal to 0.5. Look at how close these answers are. Delta y is 0.53, dy is 0.5. So what this amounts to is an observation that dy, the differential, is very closely approximated by delta y.